Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 1020 that says number of enclaves. So guys, this question is almost similar to yesterday's daily problem, that is number of closed islands. So if you guys have any doubts in this question, that is number of closed islands, or if you haven't solved this question, then I highly recommend you to solve it now. Before solving today's daily challenge, solve this question, okay? And I have already made a video on this question, so if you have any doubts in this question, then make sure you first check out my video. So today's question, number of enclaves, is just a follow-up question of the yesterday's question. So yeah, that's why I am highly recommending you to solve yesterday's daily challenge, then come to today's question, okay? And also I will compare both the questions so that you will understand that there is a small complexity added to today's challenge. Otherwise it is just same as the yesterday's. Further guys, in this video we will discuss two approaches. One approach is would be done using DFS code, and another approach would be solving using breadth-first search, that is BFS code. So yeah guys, stick till the end and watch the complete video. Okay, so guys, here you are given one m cross n matrix like this, and where a grid means containing zeros and ones, binary matrix grid. So 0 represent a C cell, that means a water, and 1 represent a land. 0 means water, 1 means land. Now what you have to do is you have to return the number of land cells in which you cannot walk off the boundary. Okay, so as you guys can see, the cells like this is a land cell, but from this land cell, in whatever direction you travel, you cannot come to the boundary. See, this is the boundary, right? This is the boundary, this is the boundary, you cannot come. But this land cell, you can come to the boundary, right? You can walk to the boundary. See, from any cell you can walk in 4 directions. So if you are connected to any of the cell that is connected to the boundary, then you can walk, otherwise you cannot. So guys, that's the move that you have to you can have to travel from one land cell to another land cell such that you reach the boundary. Yeah, this is your goal, to reach the boundary. And yeah, we need to return number of land cells from which you cannot walk off the boundary. So like cells like this is one cell, this is second such cell, this is third such cell, where you cannot walk off the boundary. So yeah, we need to return number of such land cells. Okay, so I hope you guys have now clear understanding of the question. Okay, so yeah guys, as you guys can already see that here there are 3 such land cells that you cannot walk off the boundary. So yeah, we written 3 here. Now in the second example, you can see even this cell, so this land cell is connected to this. So from here you can walk here, then you can walk here, then you can walk off the boundary. Here you can also walk off the boundary. So all the land cells, wherever you are from here, from any of these 4 land cells, you can go to the boundary. So yeah guys, that's why we written 0 here as our answer. So yeah, I hope you guys have understood today's challenge. Now if I show you the yesterday's challenge and compare, so in yesterday's challenge the difference was, see, yesterday they were using 0 for land and 1 for water. This is the first difference they were using, and the second difference they were using is you need to find closed islands. See, so yesterday they were considering this complete thing, this complete land as the one island. So they were considering this complete land as one island. This is one island in yesterday's question. This yesterday question. They were okay. So you need to count such islands. How many closed islands are there? Okay, like this, surrounded by water. So number of island surrounded by water. This was the yesterday's problem, and today's question, this was yesterday's, and today's question is nothing but number of land cells that are surrounded by water. See, for a land cell, if you cannot travel to the boundary, that means it is 4 directionally surrounded by water. This walking of the boundary is not possible. That means it is surrounded by water. It is one and the same. So yeah, this is today's question. So yesterday's question is just you need to find number of islands, and now in today's question, from each of those islands you need to count the number of land cells. Yeah, number of land cells surrounded by water. Simple it is. So yeah, that's why I told you initially only that yesterday's question is very much similar to today's question, and today's question you can see is a follow-up. This is a follow-up of yesterday's question. Okay, so yeah guys, I will be using the understanding part of yesterday's question today. So that's why I am more focusing on yesterday's question approach. So let's move to today's question. Let me take a drop back. So yeah, as you have to count total number of total cells you need to do some traversal, right? You need to do some traversal. The traversal can be what, either BFS or DFS. Okay, then one thing you need to check always, that if it is surrounded by water or not. So you need to check this, surrounded by water, this condition you need to check. And if this is true, if true, then surrounded by water. So along with these, maintaining the condition of is surrounded by water, you need to also keep a count of land cell. And if true, then what we will do, we will return number of land. And if false, then we will return 0. Okay, simple it is. So yeah, either we will discuss both the approach, the BFS approach as well as DFS approach. We will keep track of this condition, if it is surrounded by water or not, and we will also maintain the count. Now if it is surrounded by water, then we will return the count of the land cell, else we will return 0. Okay, so this is the simple logic. So this logic I have told you here is nothing but a logic that I have used in the DFS function call. So that is another approach to solve this question. Okay, so here this approach I have used in DFS code, and this another approach I have used in BFS code. See, this with the same approach you can also write BFS code, nothing new here. And with this approach, another approach also, you can write DFS code. But yeah, in this video I will discuss BFS code for this, so I will cover both the approaches as well as both the code. Got it? Now the thing to notice here is, so guys, as you can see here, that here we have this as the land cell, this as a few land cells, and here two as a these two land cells. Okay, so here in what we do in the BFS approach is, see, we try to run BFS from boundaries. What we will do, run BFS from boundaries and visit all possible land cells. Okay, so let's say this is the boundary. From here we are starting, and mark this as visited. We will mark this as visited. Okay, all the cells we can visit. Now afterwards, this is one boundary and land cell, visit. Okay, now, and no land cell remaining on the boundary. Okay, no land cell remaining on the boundary. So afterwards, the other cells that are unvisited, this is not visited. So the unvisited land cell are our answer. Simple it is. So yeah, in this situation, what is unvisited land cell are answer. Simple it is. So yeah, we will use this approach to solve to write the BFS code. Okay, clear? So yeah, now let's move on to the coding part, where we will discuss both the code for the DFS as well as BFS approach. So guys, here in this DFS approach, as we are traversing from the land cell, see here in this DFS approach, what I did, I ignored the boundaries. Okay, see, yeah, let me take one land cell again. So guys, now look at here. What we will do is, in this DFS function call, that we will try to find the land cell that are not present at the boundary. See, we will skip the boundary. These are skipped. Okay, this boundary cells are skipped. We won't try to traverse from here. Okay, these are the skip. See, because we are taking from 1 and up till r-1 and c-1. Okay, this is less than. So we won't check for the boundary. Okay, clear till here. Now if a land cell that is not present at the boundary, okay, then what we will do is, then we will check if the land cell is surrounded or not, surrounded by water or not. Okay, the same code we wrote yesterday for the yesterday's solution. Okay, the same code we wrote. So let's say this is the land cell and it is surrounded by water. We will check. Similarly, we will check for this. So since we are doing DFS, so if you start from here, then you will visit all these cells, correct? So yeah, for each land cell we are moving up, down, left and right, and we will check if it is a boundary cell or not. Okay, clear till here. Now if it is a let's say if it is a boundary cell, so then we will return 0, because that is not closed, right? We need to find cells that are surrounded by water, and if it is a boundary cell, then we would return 0. Okay, like if it's something like this, then we would return 0. And else, in the else case, what we are doing, we will simply return 1. Okay, we will simply return 1 here if it is surrounded by 0. Say if the grid of ij equals to 0, then we will return 1. So at the end we will take AND operation, and that means it is surrounded by water in the up direction, in the down direction, and in the left and in the right. That means it is surrounded by water in all 4 directions. Okay, then only we will return true. Then only this is a boolean function that we wrote yesterday. We are using the same function. The only difference we did is we took one variable count, and we simply incremented the count. Okay, see, this is n person count, so we are taking one variable and not creating its copy. So this same reference variable we are using here. We are incrementing the count whenever we visit new line cell. Here we visit new line cell, we are simply incrementing the count. And if the DFS will return true, then we will add those count to the answer. If DFS will return true, that means it is surrounded by water. Okay, got this? This is surrounded by water. Then only this DFS function will return true. And if it is returned true, then we will add all those count of length cell that we have visited in the current DFS call to our answer. Got this? Clear till here? So I guess all this code was like 100% similar to yesterday's code. Only difference we took here is the count variable to count the number of length cells. That only the additional thing we have to do. First we are checking if it is surrounded by water, and yeah, if it is surrounded by water, then the count that we are maintaining, then we'll add this count to the answer. Got it? Clear till here? Okay. So guys, in the BFS code, as I have told you, that what we will do is, see, this is one visited area we took. Then we will traverse from all the 4 boundaries. It is the first column, last column, first row, last row. We will try to make BFS call from all the 4 boundaries. Okay, we will try to make BFS call, and what we will do, we will try to mark as many line cell visited as possible. We will try to visit as many line cell as possible, and after that, if the grid of ij is equal to 1, that means it is a line and it is not visited, then it is our answer. So let me show you by a dry run. Okay, so let's say you are starting from here, this cell. So this is a boundary cell, right? So you are starting from this boundary cell. Now afterwards, from here you can try to visit this, you can try to visit this. Okay, now all these are visited, no more cells can be visited because there is water on all 4 directions after this. Now this is another boundary cell, so you visited this, you will visit this. Okay, now further you cannot visit. Now here so you have visited all the boundary cells now, right? All the boundary line cells. So these cells are not visited. Okay, these cells are not visited, correct? So what you will simply do is, all the cells that are not visited, you will simply add to the count, right? You will increment the count. If a cell is land and it is not visited, so you add to the count. So this is the simple way of we are doing BFS here. Okay, so yeah, I hope you guys understood both the approaches as well as the coding part, right? Now talking about the time and space complexity for the approaches. See guys, the time complexity here would be big O of m into n, that is the size of the grid, and the space complexity would be also same, m into n, right? Because for this much size, we are forming the visited array, and total number of cells are this much, so that we are visiting these cells, right? So that's for the time and space complexity part. So yeah guys, that's all for this video. If you guys have any doubts, then do let me in the comment section. Make sure you like this video and subscribe to our channel. Thank you.